And we are back. Okay, so we need to do a little bit of optimization because we basically need to draw all these offset pixels and whatnot twice in the situation where shadows are enabled. And we should probably also put in some measure of safety checks to make sure that the target position doesn't fall outside our image buffer. The reason for doing this is to allow the line height to become less than the glyph height, and thereby cutting off the height of the glyphs that are being rendered. Um, so, because when we do the, where is it, right here. When we do the measure string to figure out exactly how big this image needs to be, it takes into account the line height as far as I remember. Let's see. Yes, it uses the actual line height to specify the height of the text that's about to be rendered. So this could potentially be a height that's lower than the actual glyph height. So if it is lower than the actual glyph height, then doing these will in effect end up in a position that's beyond the size of the image buffer array. So we need to put some measure of um, safety in there to prevent us from attempting to draw outside the buffer size. Okay, so for all of this stuff, we need the positioning, we need the line width. We'll do that calculation within the method and then do these. Yes, okay. So we'll grab a couple of helper methods to take care of this entire setup. Let's grab a fresh method here and we'll call this draw glyph pixel. Let's see, which would take the X and the Y position that we need to render it at. So basically what I want to do is have one method that does the calculation and attempts to draw the pixel to the buffer regardless where it is, but still make sure that it's inside the size of the buffer before attempting to copy it over, which if it's outside it'll cause an exception, which is not good. And then we'll do another method that basically takes the initial X and Y position, which would be the pixel X and the pixel Y positions, and then basically perform all of this stuff for us, including all those offsets and whatnot, so that we can basically just place a call to that. Yeah. Let's see, for this we need to work out a couple of things actually. Draw glyph pixel, and let's see, what do we need? We need an X position and a Y position. We also need the pixel color that we need to draw, and we actually also need the line width passed, so we'll pass that as well. And of course the image buffer. So we will line width, and then the pixel color, and of course the image buffer that we are attempting to draw to. Okay. Whoops. Yeah. There we go. Okay, so in here we need to basically grab, let's grab this one quick and copy it up here. So we basically need to convert these arguments into this setup so that we can correctly place this particular pixel in there where it needs to go. And then put in a check to make sure that the target position is within the size of the image buffer itself. Okay, so we'll do the target position calculated from the Y that's passed, as well as the line width and the X. There we go. And then we need to work out whether we actually should perform the copy or not, depending on what the target position is versus the size of the image buffer. So we'll get those set up. So if the target position is less than or equal to the length of the image buffer minus 4, because the pixel color array will always be have a length of 4. So if the target position is less than the image buffer length minus 4, then perform the copy. This is to ensure that we have that we are within the size of the image buffer. There we go. Alright, so this one now takes care of rendering that particular pixel at this particular specified X and Y position. The next one we need is a method that will accept an X and a Y position, and then basically place a call to this one, rendering the pixel where it needs to go, including those offsets for the whatchamacallums. Let's see, for bold, for strike through and strike through bold, as well as underlined and underlined bold. And on top of that, we also need to calculate in the placement of the letter spacing, because both strike through and underlined follow the length of the chat element. They don't follow the width of each individual glyph. So that's something we need to add to it as well. So the actually one thing that we could do is that the entire setup of rendering all of these glyphs, we could do a method that accepts or returns the glyph width as well as the letter spacing, so we can increase the draw X position whenever a glyph has been rendered. So we might as well do that. All right. So this one takes care of drawing the pixel, and this one will then draw the glyph, draw the glyph itself, including all of the chat element formatting stuff. So let's see. We need to pass the, let's see, we need to pass the loop through the glyph. Yeah, we might as well just do that. So we'll pass the glyph index and then basically grab all of this and migrate that up there. And do some of these calculations up there as needed. So what kind of arguments do we need? We need, we might, yeah, we'll change this to return. Actually, we'll just void that. Yeah. And then we'll do this instead. Draw X, Y position, and then we'll need the glyph index. And then, of course, we also need to, let's see, work out, yeah, we still need to pass the chat element so we know exactly how this should be rendered. And then we can move the color conversion and such up here as well. So we'll just accept a chat element and then do all that conversion stuff in here. Yeah, glyph index. Yeah, actually, yeah, we still need to know whether to draw in. Yeah, we'll pass those as flags instead, I think. Let's see, what kind of flags do we have? Let's do a quick check here. So for this, would you mind? Thank you very much. So we need to check for bold. Let's see, the color stuff, we'll just pass the byte arrays. Italic, of course, needs to be in there because at some point we will add that in. Obfuscated for the moment, yeah, we will support it when sending the messages to the server, but in terms of rendering them, we'll see if we can work out something. I'll add that in. The strike through. I'm just noting these down quick. And of course the underlined. There we go. All right, so we probably need to pass those. Which would be this one. Yeah, okay. Does this need to be bold, italic, obfuscated, strike through, and underlined? Whoops. There we go. All right. So, here we need to grab this loop. So let's see if we can find that one down here somewhere. Should be this one. Yep. Yeah, right there. Okay. So move that stuff up here, like so, and then we'll get all this stuff fixed. And then, of course, we need the actually, I think we will just pass the let's see. Yeah, we are still getting the colors here, so we'll have to pass the colors to prevent these from having to be executed every time we draw a glyph. So yeah, we'll pass those. Okay, so we will also need a forecolor and a potential shadow color. There we go. And just for the sake of getting all these parameters more visible, I'll do this. There we go. Okay, so all right. Let's see. All the stuff that goes wrong right here would be the pixel line width, which is pre-calculated as well, I think. Yeah, it is. And the strike through Y position are also calculated, so we might as well grab those as well, which would be here. Let's see, the pixel line width and the strike through Y. We'll put those there, and then we update this stuff. Of course, we also need the image buffer, so we shall add that as well. Image buffer, and then we'll do some variable renaming here. Okay, so this one is the yeah, this loops through. Actually, we should probably, yeah, hang on, we'll move this back down. The only thing we actually need to do is to do this stuff, because this is the stuff that will be copied. Yeah. This is the only stuff that needs to be copied, because we're doing one for the shading and one for the normal. So this will, yeah, we'll need to change this again. Yeah, well, this should let's see. Draw glyph pixel, that's actually what I wanted to call the other one, so slight naming problem here. All right. This is the one that draws the actual pixel to the memory image buffer. Glyph pixel to image buffer. There we go. And then we'll call the other one. There we go. Much better. Okay, so we need to know the X and Y positions, which we get from pixel X and pixel Y, and then we'll do all the offset stuff in the other method, so we can place those correctly. So we need to pass the X position, the Y position, and the pixel line width, because the other one here needs it. So pixel line width, as well as the actual pixel color and the image buffer, so we can correctly stuff it in the memory. Okay, so the first one would be this one right here. Let's see. I'll add in another method here that does all of the formatting stuff, and then this is the one that will call to either draw the shadow effect or the foreground effect. And this would actually be formatted glyph pixel, which means it needs to go up here, like so, and then this is the one we'll call. And this one takes care of basically going through this entire setup with the initial pixel with or without the offset, do the bold stuff, do the glyph positioning, blah 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 blah, all this stuff. See, this one we can't reference because that's yep. Okay. So the first one would be at the actual X and Y position, unless of course it's a shadow thing. Let's see, glyph pixel, that would be the color, so yep. Okay, so draw glyph pixel to image buffer, which would be the X and the Y position. That one plus the pixel color and the image buffer. Whoops. There we go. Alright, so that takes care of the regular pixel. Next up would be the one where we need to figure out whether it's bold or not. Okay, it's gonna be a mess of passing stuff around, I think. Yeah, we'll do this differently. This is just getting way too messy. So I think we'll just rename this back to like so, and then do them from down there instead. We'll still need to replicate this, but nothing much we can do about that. Okay, so this would be the pixel X, pixel Y, the line stuff thingamajig, that one, the fore color, and the image buffer. There we go. So that takes care of this. Alright, so see, I really would like to have all of this in one method, but unfortunately that means replicating a lot of it across, which I really don't want to do. It's gonna be messy. Give me a sec here. Yeah. For this, we will need to see one of them would be offset and the other one wouldn't. And the major difference would be the forecolor and the shadow color. So X and Y position plus the width plus the color needed and the image buffer, and of course this particular setup as well, which would not work for the offset shadow unless we do this as a we'll have to do it this way. Otherwise we're gonna have to pass pretty much every variable in this method anyway, so we'll just reduce this and do place calls to draw glyph pixel because it internally makes sure that we are not drawing outside the image buffer. So this one needs an offset of 1, so that would be the pixel x plus 1 and the pixel y and the pixel line width, the forecolor and the image buffer. There we go, reduces this. And for this one we need to use the actual strike through Y position that was calculated. So we'll use that as well as the X goes first, dude. There we go. And the pixel line with the forecolor and the image buffer. There we go. That takes care of this one. And this one would be the same, except the X position is offset by 1. So we'll add 1 to it. There we go. Reduces this a bit. And then finally this one, which would be the, let's see, X position and the glyph height plus 1, pixel line width, the forecolor, and of course the image buffer. There we go. That takes care of this. And finally the same thing, except the there we go, X position offset by 1. Alright, so this has now become a little easier to read. And of course we're gonna need all of this once more for all the shadow stuff, except all of the positions need to be offset by 1 on both the X and the Y axes. So we'll grab this. I hate copy pasting, but it'll be a lot more work getting all of this stuffed into a separate method. So we'll accept this. Okay, so pixel X plus 1, pixel Y plus 1, and then this of course is now the shadow color. So all of these instances of forecolor need to be replaced with shadow color. And since this is bold, we then need to increase this by 2 instead of just 1. And reference shadow color. There we go. And again here, +1, +1, and the shadow color. And here it's +2 instead of +1, and shadow color. There we go. And again here, increase by 1 from what it was. Do the shadow color, and 2 and 2, and of course the shadow color here. Alright, so one thing that is still missing here, we don't need the target position anymore because the draw glyph pixel takes care of that. One more thing that we need to add in here is something that will render the strike through and the underlined, including bold and the shadows for it, for the line spacing, or sorry, letter spacing. And that basically is looping through it to render those as needed, and basically increase the draw X position as we draw those extra bits. Let's see, this is the glyph position, that's the glyph height, so somewhere here, which should be that one. And once this is done, increment the draw X by the glyph width. So we'll add the current glyphs, which would be the glyph index and the width of this one. There we go. So now we've moved our current draw pointer X position up to past the glyph that we just drew. And next up we need to go through and process strike through and underline, including the shadows for the letter spacing. So and for that purpose we basically only need to do the X position, and then from there we already have the glyph height, the strike through Y position, so those should be fairly simple. Let's see, do we have the we won't have those, so we'll have to come up with something for those. Okay, so this would be the letter spacing. Letter spacing. And here increment the draw X by each pixel of letter spacing. So here, whoops, just add one to it. If I could hit the right key, there we go. All right. So here we need to shadow and then normal. And since these are already set, we effectively only need to check if shadows are enabled and then go through this entire setup based on, since we don't have the pixel X at the moment, that would become the draw X plus the L, so that should be fairly straightforward as well. I'll grab this, that's the shadow. So if shadows are enabled, then we need to process this. Strike through, which would then be pixel X, and that then becomes draw X plus L. and the rest of this is correct. If it's bold, then it needs to add yet another one, draw x plus L. There we go. That takes care of that part. And again here, the draw x plus L. And finally down here, the draw x plus L again. That takes care of all the shadow stuff. And then we need to do the same thing for the normal, which would be right here. There we go. And place that down here. And again, pixel x needs to be replaced with draw x plus L. And draw x plus L, whoops, like so. And finally down here. Now, if these text formatting options are not enabled as part of the customization, all of this processing stuff will of course be skipped because it doesn't have to be done. So there, that takes care of this particular setup. And once we are done doing this, we will have an image buffer that we can then copy into an actual bitmap object that we can then draw on the form. So let's see if we can get that done and see what kind of trouble we can get ourselves into by doing a couple of runs on this. Okay, so we have the image buffer. We can use the surface size variable to determine the dimensions of the bitmap that we are about to create. So let's get that copied, all this stuff copied over. So we'll need a new bitmap, and that bitmap needs to be the size of the surface that we have just rendered on, and this needs to be in a format 32 bits per pixel ARGB. There we go. And since we won't be utilizing any of the bitmap methods as such, we'll simply just copy the byte buffer that we created into the bitmap. We will lock the bitmap that we just created so we can do the bit transfer stuff. So to do that, we'll lock the bits. We'll have to tell it the area that we need to lock. So that would be starting at 0.0 and using the surface width and the surface height. And then we need to tell it what kind of locking mode we need. We need to write because we are copying from the byte buffer into the bitmap. So we'll write, and we'll just use the pixel format from the bitmap itself. Then we need to do a copy from our image buffer starting at 0 to the memory buffer of the to the memory of the bitmap, sorry, and of course using the length of the image buffer that we had. And when we're done doing that, we need to unlock so that we can utilize the bitmap afterwards. And since we're done here, we might as well just kill the bitmap data. And since we are done, we can also kill the image buffer array. So we'll just trash that quick. Job done, and then return the resulting bitmap. All right, so even though I have done these things hundreds of times before, if not thousands, there's always the chance that some kind of bug has crept in somewhere, oversight or incorrect math, stuff like that. So we could risk that this might end up with some kind of crash somewhere. But then we'll just go through it and see if we can debug and figure out what's wrong. Let's see, this one creates the bitmap, and this one lets us draw it to an actual surface. So why don't we just do that right away. And let's see, we should always get an actual bitmap result from this one, so that should be fine. So this would be the draw image, draw string, and pass the chat text, and then draw it at this point. There we go. So this is this second overload is basically just to let us use any graphics object to draw it onto a surface that could be a different bitmap, or it could be in the paint event of our custom dialog stuff. So we can do that as well. At the moment, it only draws a black surface, and we then need to add in the actual rendering of the customized text. So down here we will check to see if what's it called, txt text contains something. If it does, then we'll see if we can render it. So if that one has a trim length greater than 0, then we'll see if we can actually render this stuff. So mcfont.drawString, we'll grab this one and then reference that one, the graphics object of the form, and then we'll place the actual rendering of this stuff. I don't know. Let's do it at 15 by 15 and see what happens. Okay, we'll see. Da-da-da-da-da. No crashing, but we definitely did get something up here. All right, let's start by doing something. Oh, we forgot to add in the text changed event. So let's grab that quick, like so, and we'll see if we have a control event right here, for example. If the text changes, then we'll simply invalidate the form, which would then force a re-render of the text. There we go. So let's see what happens if we change some of this stuff. Question mark. LN server 7 scheduled server restart in minutes. Okay, so pretty straightforward. It's actually rendering up some of it at least. We get a gold. Let's see if we can do what's the code for strike through again? That would be the M. Let's see if we can get a strike through of, let's say, here. So M. It's not particularly evident, but it actually adds the strike through to it, though something gets overwritten somewhere. So we'll have to look through the strike through code to see if we can figure out why it's not rendering the strike through correctly. If we change that to an N, we should get an underline, which we don't seem to be getting. So for that, we will probably need to check whether we're actually getting the positions correct. They might not be. Actually, I know for a fact that they are not, because we're adding +1 to the glyph height, which means it's actually drawing the underline at the 10th Y position instead of the 9th as it's supposed to. So let's go fix that right away. And for that, we need to have a look at this to begin with. So underlined is right here, and it says glyph height +1, which means 9. And since we are counting from 0 to 8, placing it at the 9th position actually places it outside the height of the image we're rendering to. So this actually needs to be the actual glyph height itself, and not +1. So that's that. We need to fix it on the shadow effect as well. So we'll do +1, which of course will fall outside the height, but again, it's not a huge issue because draw glyph pixel internally handles basically buffer overruns. On the letter spacing stuff, again, we need to do the repositioning of the underline. So +1, and down here it's just the glyph height, like so, and like so. And then that should take care of this. And then yeah, we'll see if we can fix the other part. Okay, so now stuff's happening. Let's see. We'll get rid of some of this stuff to begin with. There we go. Not quite sure why it puts a question mark at the beginning. Oh well. Let's see. What happens if we put N right there? So at least the underline for the letter spacing seems to be working. It's not working for the glyphs themselves, so something went wrong in there. So that's definitely something we need to debug, and for whatever reason it puts a question mark at the beginning of it. Not quite sure why, but we'll see if we can figure it out. That's kind of weird. Huh. Well, it might be, huh. That's definitely different. So what's the bold, where is it? There we go, L. Let's put that there. So bold at least seems to be working. That would be this one. Yeah, bold seems to be working just fine. Except it's actually not correctly placing the letter spacing as it should. So minor bug there, which means whenever we have a situation of a chat element being bold, we need to add 1 to the letter spacing apart from the rest of it. So we'll see if we can take care of that. But at the moment, it's kind of small, the text that it's rendering, because we're doing the normal size of the glyphs, which of course becomes pretty tiny when we're on a higher resolution. So I think we'll go through and see if we can do the double up stuff and see if we can actually, you know what? Let's see. Yeah, grab this drawstring. It's fine. Okay. Let's see if we can do the double up, double size, which is something that, of course, we need to set in here somewhere. So where is the set glyph? Bitmap is right there, and then we'll set the double size to true. There we go. We could potentially change this to simply be an integer that says 1, 2, 3, 4, for example, indicating that each pixel should be the size squared, and then have the font renderer upgrade the actual rendering accordingly. If we do it that way, then we could potentially specify any size and basically have it render it in that particular zoom just by doing the calculations for it. All right. So to do the double size stuff, we kind of need to correctly update our image buffer, the surface size, and of course also how this particular method draws each individual pixel. Now, in terms of us using our own code here, I feel it would be easier if we only have to specify the X and Y positions of the pixels that we want to render, instead of us having to do a lot of the size calculation stuff. So I'm gonna change these methods and stuff so that we keep the actual pixel positions, and then let the individual methods and buffer sizes and such be handled by basically a zoom factor. And the zoom factor then determines whether we can do a single pixel copy like this, or whether we actually need to loop through and do multiple placements of these within the image buffer itself. That way we don't have to change a lot of all the other handling code for drawing the glyphs, and we can just change basically these offsets as needed whenever we need to change them. Granted, I'm aware that we still need to fix both the strike through and the underline stuff, but I wanted to do the zoom stuff now so that it'll be a little easier for us to actually see what's going on with what's being drawn. So let's see if we can work that out somehow. Okay, so Yeah, why don't we fix this right away? Let's see, we'll call this zoom size instead, and then set that to say 3. And rename this one to public int zoom size. And then we'll probably need to, yeah, we'll do that here. And then zoom size, and default that to 1. Return the zoom size, and then we'll ensure that zoom size cannot go below 1 and cannot go above 4. Those are the UI scales that the game client has to offer. So if the value is greater than or equal to 1 and value is less than or equal to 4, then we'll do the updating, and that should be it. So put that in here, property, zoom size. There we go. All right, so we can now utilize the zoom size variable to determine the size that we need to render the font in. So that would basically mean that building our image buffer means we need to multiply these by the zoom size, like so, and of course still by 4, because each pixel takes up 4 bytes of information: red, green, blue, and alpha. So this now correctly scales to whichever zoom size we've set. Or maybe we should call it zoom factor, I don't know. Nah, we'll just call it zoom, that should be enough. Yeah, I know. I know. There we go. This one needs to be changed as well. There. And then rename these, and then we should be fairly good. Alright, so down here, when we are about to copy the image buffer into the bitmap before returning it, we again need to up this by the zoom factor so that we get the correct size. And the same goes for the rectangle down here, of course. And that takes care of that, and we should be good to go. The one thing that we still need to do is to update the draw glyph pixel method to be able to handle this zoom stuff. So here we kind of need to work out whether we can do just a single setup or whether we have to do basically a looped setup to correctly place these pixels that need to be drawn in. So for the sake of keeping things default and keeping this in place, if the zoom is set to 1, that means 1 pixel position is actually only 1 pixel, and if the zoom size is greater than 1, which our property takes care of handling for us, then we need to basically loop through and draw zoom squared copies of the pixel, and then of course also cross-calculate the final positions of x and y. And the line width is still should still be correct. because the line width calculates based on the pixel sizes and not the actual zoom size, so should be fine. Okay, let's see if we can get this calculated correctly. So we know that for every X and Y position, we need to place zoom X pixels and zoom Y pixels, so we kind of need to loop through these and then recalculate the target position for each of them. That basically means we need to go through a couple of loops here so we can properly upscale and position these pixels that are about to be drawn. So this would be the zoom Y, which needs to zoom Y like so, and then we need an inner loop for the X, and CX++. There we go. Okay, so actually I think I'm gonna do this quick and then remove that so we can reuse it. Alright, so for every one of these we basically need to recalculate this position based on where we are at the moment. The target position will, and as we can see above, y equals line width plus x times 4. So the times 4 we can put pretty much anywhere in this setup we want, as long as we've calculated the correct placement. So for the x, that needs to for the y, sorry, that needs to be the y multiplied by the zoom factor, and then we actually need to add in the zoom y position as well, so we can get that placed correctly, because we're looping through however many pixels we need to draw, like so, and the line width, and over here again we need to multiply by the zoom factor so we can get the correct position, as well as adding the zoom x, like so. There we go. That puts the target position within the zoom pixels, and then just as before we need to make sure that we don't fall outside the buffer, so we'll grab that and that should take care of it. So let's see if we actually end up getting a zoomed version of this. That should be 3 times normal size. Let's see what happens. And we miscalculated somewhere. And this is what happens when all of the different math doesn't line up correctly. I'll get rid of these just to show them. So something definitely went wrong here. Now, the one thing that I forgot to put in was, of course, the line width calculation, because the line width here, of course, also depends on the zoom factor. So here we also need to multiply by the zoom factor to get the correct width of the line that we are attempting to render. And just to, oh, that's in the main form, my bad, down here. I'll remove all this formatting junk here, so we have a clean text to work with when we start open up the dialog. There we go. Boom. Now that's a lot better. Now at least we can see the text. Granted, it's kind of running outside the size of the form, so why don't we set that to a zoom factor of 2 instead, if I can find it. There it is, like so. And that's a lot better. But as you can now see, the zoom feature actually works the way it's supposed to. Let's see if we can put in some color stuff here. We'll put this like that and do that. And then from here we'll do scheduled server restart in 10 minutes. We'll do, what's this supposed to be? C, I think. Yep. And then do the E again, and we've got a nice colored text. Pretty cool stuff. Okay, so the next thing that would be interesting to see is how the bold actually renders. So let's grab this image quick, and we'll grab this again. So bold would be the L. So let's see what happens if we and L all of it. Well, it did in fact turn bold. However, the letter spacing disappeared, as we already knew. So that's one thing that we definitely need to fix. There's no letter spacing in there now. In the original, as we can see on the image here, there is actually a 1 pixel letter spacing in here. So that's one visual bug that we need to fix in this rendering routine. And then we'll see what the strike through looks like. So well, that kind of partially works, I guess. We definitely need to work out why the strike through doesn't correctly draw the line as it's supposed to. And we have about the same issue for underline. For whatever reason, it's only drawing the underline for the actual letter spacing, which isn't particularly good, which means somewhere in our check code we have some kind of mistake that causes it to only render those lines on the letter spacing. Now, where could that be? Well, that would probably be this one. See, this one is supposed to trigger whenever we go through looping this stuff, and for whatever reason this is not triggering the way it's supposed to. Let's see, that would be because the rest of these positions should be correct, though yeah, it's those are correct. It's just not going through this process. So let's see if it actually does trigger this. Check for glyph strike through and underlined. We'll put that in the debug and see what happens. Huh, interesting. So it's not actually triggering. That's interesting. Now, why wouldn't it be triggering? Because it should actually start at 0 and end up at glyph height -1. So for whatever reason, this doesn't occur. Let's see if we can figure out why. Boom. Um, that would be because, good question. Yes, that's because these are, this particular check is being made inside solid bit rendering only. So that would basically imply that there would have to be a solid pixel at the very bottom line for the strike through and underlined parts to be rendered. So what we need to do is we need to move this outside the if bit something 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 check, and then render them on the outside. And since these are being placed in here, why don't we move them up here instead? There we go. That should take care of that particular issue. Check for glyph strike through and underline. Oh yeah, we're getting a lot of those. One for each letter that's being rendered actually. So let's see. Bold, strike through, and underline. Ta-da! Pretty cool stuff. So what happens if we do say like this and that one, and actually I want this one to be bold, and then this one needs to be 7. And here is one thing that we actually need to update the chat converter to do. Whenever it starts a new element, chat element, it needs to go through a reset process basically, because at the moment we're using a toggle feature, as you can see, and the game client renders each individual chat element as if it was being reset every time. So we need to update that part of the code to properly support this the way the game does. So let's turn this yellow, and we'll do the red, which is C, and we also want this to be underlined, which means we need to turn it off again here because our code doesn't behave like the game client does. So that's something we need to fix, and this needs to be yellow. So we could do something like this. Well, so far it looks fairly straightforward, except we're doing toggles, and that's a minor fix that we need to apply. Last thing we need to fix is, of course, the problem with bold text that doesn't get the letter spacing correctly the way it's supposed to. So let's get that fixed. See if we can get that fixed at least. That would be shadow. We'll do the regular part first. So if we have a bold in here, then we need to add 1 to the spacing for each glyph. And since this is the end of an individually rendered glyph, we need to do a check for bold here and add 1 to the X position to account for bold characters. So that fix should be fairly simple to handle. Is this chat element in bold? Which is that one, of course. Yep, so add 1 pixel offset. There we go. And that should then take care of the missing letter spacing problem for any text that is set up as bold. So let's see if we can build this one again. 9, we did this in bold, which was L derp, and toggle it off again, and then do the gray, and over here we did the yellow, and down here we did the red, and we did an underline, I think. Yep, and we'll turn the underline off, and then we'll do the rest of it in yellow. There we go. See, now we actually ended up getting the correct letter spacing for bold characters. If we want to check things out, strike through works perfectly. Underline works perfectly, with the exception of the one that was under the 10. Alrighty. Because of the toggle feature that we put in here. So we kind of need to work out exactly how we should do this, but I think I'm going to follow the basic premise of doing a chat element reset every time a new chat element is added, basically. So we'll see if we can get the chat converter stuff to do that as well. So whenever we need to add in a new chat element, which is right here, we'll basically do a reset of said chat element, which means these need to be set basically the same way, and that would be right here. So let's see how this behaves now. 7, we need a 9 in there, and a 7 up there, like so. And then we wanted a bold in here, which is the L. And now only the server word is in bold. The yellow. We need the red, and we also wanted the underline for this. Of course, this is going to change color because there's a 1 next to the ampersand. Underline is there, and then here we can do the E, and the rest of it becomes yellow. So now it should behave pretty much identical to how the game handles it internally, though we will probably have to do these checks against the game to see whether placing an underline to begin with underlines all of it or not. So that's a test scenario that we need to go through at some point. But at least we can now properly and correctly have this set up, though this resets the color, which it probably shouldn't. But yeah, we can format with bold, underline, strike through, all the different colors and such. So we definitely have a usable foundation now. The rest of this stuff is, of course, up to us to kind of go through and update the entire UI of the launcher to allow us access to this custom text dialog thingy. we still need to add in things like, as an example, all of the different colors, as well as some extra buttons for bold, italic, strike through, and so on and so forth. So we can basically use some graphical elements to say highlight this part of the text, and then say click a yellow button, and it will then automatically add in the yellow tag like this. And I'm kind of interested to find out why it puts a question mark up there. Ah, right, I wanted to get rid of that debug stuff. Forgetful, forgetful, forgetful. There we go. This stuff needs to disappear, and then I think I would like to do a quick dump of the ASCII text here. Just to see exactly what it is. It's dumping that becomes a question mark there. Chat element number. There we go. And then loop through those ASCII text elements and basically just dump them for debugging purposes, so we can see exactly what they are. Diagnostics, debug, character, plus a, which is ASCII text, a toString. There we go. Okay. And would of course help if I finished that. There we go. Let's see what's going on here. So I put in a yellow color there, which caused a question mark to pop up there. So let's go through these. Basically, let's see. It places a 63. Let's see. The 91 and then 93, that's the bracket begin, that's the bracket end, S-E-R-V-E-R. So character 63 is exactly what? Let's see, that's that would be the question mark, yes, but why is it being converted into okay, so something is apparently being added to the beginning of the process. So whenever this, okay, yeah, that's part of the conversion problems that we sometimes run into. For whatever reason, it decides to convert whatever weird character is at the beginning of this, but I guess I could just right. Yeah. Stop. Let's go through and dump this quick and see what's going on. Chat elements, e-text. text length, and we will do a debug right line, and then cheat a little bit here. UTF, and then this would be the t toString equals plus, then we'll int convert this text t and toString it, so we know what it becomes. And this should actually be down here, like so. Let's see. Not quite sure what it decides should become. Let's see. So chat element 0. The first one is character 167. There's no character 167. Ah, okay. So 167 should be the section symbol. So somewhere in the chat converter, it leaves behind the section symbol when it splits the individual parts into the chat elements, which should be evident by doing another quick debug element, and we'll add in the toString, and then fetch the actual element itself there. And since the section symbol doesn't really exist as part of our glyph stuff, we kind of run into a problem there. Yes, as you can see, in the first element, it adds in the section symbol there, which should not be there because there are no other kinds of formatting characters. So we kind of need to fix that particular bug, and that happens because the assumption is that there is an occurrence of the section symbol, since the toMOTD method always ensures that the section symbol gets placed back. So up here somewhere there's a bug that prefixes in here somewhere there's a bug that prefixes the section symbol if more or less regardless, which of course it should not do. Or is it down here? No, it's probably down here. Yeah. So let's see. Yes, this would be the assumption. So if we run into the situation that we don't get a position for the control codes, and this is the first instance, then there is no initial code. So here we kind of need to make sure that P is greater than 0, and only then add in the section symbol. And that should then take care of that particular issue. So let's give it a try and see what happens here. And problem solved. Nice. Alright, so custom rendering of text. which for the most part should follow what the game does. However, it's something that we need to do a proper check on to see if we've got this stuff set up correctly. I don't particularly like this gray and blue setup, but whatever. Let's see. Now we'll make this gold instead, and then we'll do, I don't know. Yeah, we. I wanted the bold, and I also wanted the underline, and then over here we'll do the C, and boom, we're done. Oops, that should be gold, I guess. There we go. Nice. Scheduled server restart in 10 minutes. Blah, 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 blah. All right. At least now we're one step closer to having at least something that can show us what this may look like as part of the game client. But just for the sake of checking some of the other stuff, let's see if we can update the dialog to have it include shadows and see if the shadows are rendering correctly. This might be a little bit difficult to see on the stream, but we'll see if we can set it up somehow. Let's see. D A. It's actually pretty difficult to see, but the shading is actually there. As far as I can make out. Yeah, it's there. Nice. So at least some of it is working. Strike through, underline. Ha 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 ha. Nice. Okay. All right, so we can add in the shadows, whether we need to add them or not. Well, for the sake of showcasing stuff as a custom preview, I guess we don't really need it, but we do have a rendering thingamajig that can actually do it. So cool, cool, cool. All right. Now that we have, let's get rid of this again. Some of this stuff, at some point we may need to add in a customized ASCII conversion because if I grab a perfect example, if I add in things like this and this and this, then they will all render as question marks because the built-in text encoder is not quite capable of converting these into the proper glyph references that we know that we have available. So to support these, we, as well as some of the French special characters, we will have to implement some form of custom text conversion from the standard UTF-16 format that Visual Studio or C# uses into an ASCII format glyph index table that we can use to fetch the correct glyph to render when somebody types in these special characters. For pure English language setups, it's not really required, but it's something that I at least would like to implement at some point. Whether I do it on stream or off stream, I might just create that custom ASCII converter off stream because I know that I'm gonna need at least support for Danish letters for one of the two servers that I've got running, at least at some point. So I'll definitely need that, but I'll make sure to put in proper documentation along with a bit of information on why we had to do this. In any case, at least this part seems to be working nicely now. The only one of the control codes that we currently cannot support is the obfuscated stuff, which would be the K, I believe. So let's see what happens if we put in K. The reason we can't support that at the moment, yeah, it does read the tag correctly, but at the moment it's leaving the text as is because I honestly didn't want to build up something that basically cycles through random selection of characters just to simulate that particular setup. It's something that we can add in at some point if it's really needed. I should probably do some kind of glyph randomization on this for the contents of that particular chat element, I guess. Yeah, we'll add that support at some point if needed. At the moment it's not important because most of these texts that we need this for will be informational texts that A, show up in chat, and B, show up as the introduction text for the server in the MOTD, similar to what Applecraft has done here. So the only other thing that we really need to add in support for would be support for the new line for the MOTD setup. So that's at least something that we need to keep in mind. I'm kind of thinking that at some point I'll see if I can work out exactly how big this area is in terms of pixels, and then see about reconfiguring our custom text dialog, the black square, to basically have a kind of size outline thing that indicates the space available here to better support build-up of text that goes inside the MOTD for those customizations. So that's something that we will be doing at some point. For now, though, I think we will see if we can come up with a way to yeah, let's grab this again. Basically let us add in some custom buttons so we can select text like this and then click a button and have this dialog insert the needed tag to add in that particular color, or bold or underlined or strike through, whichever, and then take it from there. So we know we need to display the 16 colors, which would be these. So basically, I guess we could just cut it down the middle and set them side by side or above each other, and then turn them into clickable areas so that we can use them as selection buttons. Shouldn't be all that big of an issue doing. Whether we want to put the codes and the names and stuff on there, well, I guess it's not really needed if you have the actual color available, but we will need it for the bold, the strike through, and the underline. Alternatively, some kind of icons to do the same job. Actually, let's see if we can potentially grab some from one of my sets here. Let's see, I believe I do have a word processing set. Let's see what we can find in here. There should be some indicators for bold. There we go, character bold, small. There is a strike through and an underline. So we could potentially grab these and just use those as clickable buttons for those effects. I guess that would be okay. Character strike through, character underline, and character bold. Yeah, let's go grab those. And these are licensed, by the way. Let's see. Character. May I please have a character? There is a character bold. And there should be, guess we should grab the italic as well, strike through and underline. There we go. We'll grab these and stuff them up here with the rest of the icons right here. So we can then use these for the custom text dialog thingamajig. All right. So we'll need to import those at some point. And then see if we can work out a way to have them shown here. I guess we could put them down here as buttons. Oh, actually, might want to do a reset of some kind. If there is such a thing. I guess we could just use something like this. Nah. I don't know. We'll figure it out. In any case, those are black, and our form is kind of grayish. So we'll probably need to put some kind of background in there to get those set up so we can actually see them. On the other hand, we could basically just use this. This are set up similar to these buttons we've got here. Because it already uses a black text on top of that, so adding them in as black images on top of the grayish background thing, that should be fine. Yeah, let's see. First of all, we know that we are going to need those colors. So perhaps we should consider doing something about those particular Minecraft colors. At the moment, they are hidden away within our font rendering setup right here. for both the shadow colors as well as the regular color, which means they are somewhat inaccessible. Especially if we want to draw the or use the same color setups to at least for the normal colors, use those as kind of a button surface, so we can just click on one of the colors and have it selected that way. So we kind of need to expose these colors somehow. Now we could simply just copy these over to the form itself. Alternatively, we could create a separate class that handles the color references centralized, so we can share them across all the different places we need them, which I think I will go do. Because it will just make life so much easier. And we could potentially also add in a technical name versus indexing conversion into that color class, as well as have it be able to get a byte array or an actual system.drawing.color object, depending what we need it for. So I think we will be doing that. Yes, we'll do that. Before we go into that, though, I think it's time for a couple of minutes break for nature calls and whatnot. So I shall be back in a bit.